This is KJ here, going over part 2 of lesson 5.06 for core chemistry. We are reviewing and we're at the double displacement reactions. A double displacement reaction is a reaction in which two compounds react by exchanging ions or elements to form two new compounds. So again, our objective, identify, complete, and balance, this time for double displacement reactions. In a double displacement reaction, two compounds exchange ions or elements to form new compounds. In many double displacement reactions, one or both of the new compounds that form are in a different phase than the reactant. So what are our phases that we're going to see? Solids, liquids, gases. For example, many double displacement reactions occur when aqueous solutions, so this means it's dissolved in water, like salt water would be an aqueous solution. So many double displacement reactions occur when aqueous solutions of two compounds mix and form a precipitate. So remember, the precipitate's is going to be solid, or a gas is formed. And how will we see a gas formed? Bubbles. Another common group of double displacement reactions is neutralization reactions, in which an acid and base react to form a salt and water. And we will do an entire unit on acids and bases later on in the year. All right, so double displacement, two compounds exchange ions or atoms to form new compounds. Many double displacement reactions result in the formation of a compound in a different phase from the reactant, such as a gas or a solid precipitate. All right, so go ahead and hit pause, look through these, and say which one is a double displacement reaction. And the answer is D. The answer is D because we have two compounds and they are switching partners. So now you're going to write the balanced chemical equation for a double displacement reaction, and you have the format over here. To determine the concentration of sulfuric acid, H2SO4 solution, the student titrated it with a known concentration of sodium hydroxide solution, NaOH. Write the balanced chemical equations for the reaction of the sulfuric acid and sodium hydroxide. So hydroxide, sulfate, we definitely have some polyatomic ions happening here. So look at your polyatomic ion cheat sheet if you need to for assistance. Hit pause, get your answer, and here is your answer. So again, hit pause as you need to read it through, check your answer. And if you didn't come up with that and you need some help, definitely make sure you see me to get some help on this. All right, for the problem set, the lesson suggests doing 1 and 2. So go ahead, hit that pause button, get your answers. And we're going to put the answer up because the other ones were a little shorter, so I could just say them, but this one's pretty long. So we have our table salt, which is aqueous. All right, so if we go back to our problem, it says it's an aqueous solution of sodium chloride, right? It says right here that we have an aqueous solution. So that's how we knew for the answers we needed that AQ after it. All right, we also have the AQ here for aqueous, silver nitrate, yields silver chloride, which is a solid. And so when we go back into our problem, it tells us it was a precipitate. So that's how we knew you had to put that S there. And then we had our sodium nitrate. Now, in this case, it did not tell you that that was aqueous. They assume since one was a precipitate, you knew the other one had to be aqueous. I'm not worried about if you knew the other one was aqueous, but you should know that precipitate, you can put an S after it. That is definitely doable. All right, so then the second question was the one that gave us all of our choices for a double displacement, which again is going to be D. So we have our two compounds and they were switched within. And as always, see me if you have questions or you need some help on this. All right, last problem set coming up. Oxidation reduction reactions. So we are going to describe them, identify oxidation numbers, explains what happens in our redox or oxidation reduction reactions, and then of course balance them. Oxidation reduction reactions or redox reactions occur when elements or compounds exchange electrons. When a chemical species, so an atom, an ion, a molecule, is oxidized, it loses electrons. When a chemical species is reduced, it gains electrons. Remember, gaining electrons means the charge is more negative, so the charge was reduced. A chemical reaction in which one or more species donate electrons to one or more other species is called an oxidation reduction or redox reaction. In essence, redox reactions are like two separate reactions taking place at once. Oxidation and reduction always occur together. One reaction can't happen without the other one. Consequently, you need a special technique to balance redox reactions that reflects this electron exchange. You can do this by splitting the reaction into two half reactions. One half reaction shows the oxidation reaction. The other half reaction shows the reduction reaction. Now, this next sentence gives a specific example that you will not have to know. It's talking about what happens in acidic solutions, in that you need special steps in order to balance them. So if you're interested in that, hit pause and read it. And let's look at our examples here. So the first one says the formation of sodium chloride from sodium metal and chlorine gas is a redox reaction. The balanced chemical equation is shown below. Which element is oxidized? Which one is reduced? So let's look over here. Oxidation occurs when an atom loses electrons. Oxidation causes an atom's oxidation number or charge to become more positive. Reduction occurs when an atom gains electrons. So reduction causes an atom's oxidation number or charge to become more negative. All right, so which one of these is giving, which one is receiving the electrons? That's what it's talking about. Look on your periodic table if you need to. Look at what the charges are. So the solution, sodium and chlorine, are both elements. They consist of neutral atoms which have no electric charge. Sodium chloride is an ionic compound. It consists of sodium ions, right, that +1 charge because it's in group 1, and chlorine, that -1 charge. For a sodium atom to become a sodium ion, it must lose an electron. For a chlorine atom to become a chloride ion, it must gain an electron. Therefore, sodium is oxidized and chlorine has been reduced. This next example talks about how sometimes the charge on an atom can be different than on the periodic table. And this we go into in honors chemistry, but if it's something you're interested in, definitely hit pause and read through it because it talks about how you would calculate it. So hit pause, read through it if you want to. And then here's the rest of it. So you can pause and read the rest of it if you want to. Same thing for this one. If you're like, wow, this is really interesting how this actually works, go ahead and hit pause and read through it. It will not be on the quiz. And the same thing for this one. Again, this is not on the quiz, but it is covered in honors. And it is something where you're like, oh, this is really interesting. Or maybe you're thinking, hey, maybe I want to switch into honors. Definitely read through these. And the same thing with this one. This one is an optional read. So hit pause if you want to read it. And so there definitely is a problem set if you would like to work through these and check them out. And I'm going to hit pause if you want to see that, or you can hit pause, and then I'm going to move it down so you can see that last one, number 5. All right, and then, however, the type of question that's going to be on the quiz is going to be like this one that I'm going to show you right here. All right, you're going to get a chemical equation, and it's going to look different than the ones that we've worked with because you're going to have some charges here. It may or may not be balanced, and it's going to say which element has been oxidized or which element has been reduced. So the first thing you want to do is think of your definitions. What happens if it's reduced? Well, in terms of oxygen, does it gain or lose electrons? So it's going to either lose oxygen or do what with electrons? To be reduced, a more negative charge. So it's going to gain electrons. So the charge, is the charge going to be higher or lower? So the charge is lower. All right, so looking at those examples of what we have of our definitions, go ahead and hit pause and get your answer. So if I look at beryllium started out as +2 and ended up as a +3 charge. Copper started as a +3 and ended up as a +2. So here I can see that the charge of copper is lower. It was reduced. So we would say the copper was reduced, and we could say the beryllium was what? It was oxidized. In this case, oxygen was just thrown in there, nothing changed, just to kind of make sure you knew what you were doing. All right, as always, if you need help, let me know. Otherwise, go ahead and take the quiz.